Hi, welcome to a talk on the RF and microwave major here at Virginia Tech's Department of Electrical and Computer Engineering. I'm Steve Ellingson. I'm an associate professor here in the department and an instructor of some of the courses that comprise this major. This talk is for undergraduate students in Virginia Tech's ECE department who are considering pursuing a major or a secondary in the RF and microwave area. So once again, this talk is about the RF and microwave major or secondary at Virginia Tech. If you are interested in RF and microwave as a career area, then the right video for you is actually this one. If you haven't already seen it, you'll probably want to watch that video first. Two disclaimers before we get started. First, the details of the major will probably change from time to time, so you should consult the ECE Undergraduate Advising Office for the latest authoritative information. Secondly, course lab policies and lab activities and things that I'm going to describe will depend somewhat on the instructor. So the examples I'm showing in this presentation are from the course sections that I have taught, and it'll probably differ somewhat for other instructors. Here are the key courses that comprise the major, and first note that this is not a complete list. Of course, there are other ECE courses that you will have to take. I'm merely identifying the core courses that comprise this particular major. So ideally, what will happen is in your junior year, indicated as year 3 here, in the fall you would take 3105, which is Electromagnetics 1, and in the spring you would take Electromagnetics 2. The 2-semester electromagnetic sequence is quite important as foundation for the subsequent courses in RF and microwave. Also, in the spring of your third year, you would ideally take analog electronics, and then also 3604, which is the introduction course for the major. And then in your fourth year, you would ideally take one of the follow-on courses for 3604, those being 4104 or 4605. You would also take a tech elective in this area. Options might include 4124, which is propagation, 4220, which is analog IC design, or perhaps one of these two courses if you're already taking the other. In the spring of your senior year, you would typically take another tech elective in this area. A common choice in the spring would be 4114, which is antennas. Now, of course, not all students will follow exactly this plan, but this is intended merely to give you an idea of what the typical progression through the courses would be, and then what the typical set of tech electives would be. (3604) is your introduction to RF and microwave generally. In this course, we cover many topics in RF and microwave. The idea here is to expose you to as many topics as possible. None of these topics are done in depth. In each topic, we merely try to tell you enough so that you can learn something about the topic, come away with a design and or analysis skill in each one of these topics, and be somewhat better prepared for a deeper dive that would occur in a subsequent course. But the topics that come up include antennas and propagation, impedance matching and filters, linear small signal amplifiers, oscillators and other ways of generating frequencies, frequency conversion and mixers, analog modulation and noise, receivers and analog to digital conversion, nonlinear devices including power amplifiers and frequency multipliers. And then we always try to save some time to do special or timely topics that give you an idea of what is currently hot in the area and give you a chance to learn a little bit more about those particular topics. So 3604 is required for students who would like to complete the RF and microwave major. It's recommended for students who are doing a secondary in RF and microwave, in particular since this gives you a very broad overview of the entire area. all in one course. And I would say it's a good choice if you're not pursuing the RF and microwave major, but you're merely looking for additional depth in electronics, learning some additional aspect of electronics, or in the case where perhaps you are going to be doing an RF-based senior design project and you would like some preparation for that. This would be a good course to get that preparation. Some of the key courses I identified earlier have a lab component. For lab, we often use Whittemore Room 220. One of the benches in that lab is shown in this picture. Each bench is equipped with a suite of modern RF test and measurement equipment, as well as a soldering station, and access to additional useful material and bench stock for doing projects. The COVID-19 pandemic has forced us to become creative about how we do RF labs. Something we are trying this semester, which is fall 2021, is to use nano VNAs. A nano VNA is shown here. It's a low-cost but very capable vector network analyzer, which is also very, very small. It's about the size of a deck of cards. So this semester we have distributed these to students, and they bring them to class, that is, to the lectures, to do the labs. Because each student has one of these devices to keep for the duration of the semester, it's possible for students to do practice exercises at home and to prepare for the in-class lab. And of course, the units are also available to the students to do their own experiments at home, which is something I encourage. Speaking of lab, let me show you some examples of lab projects. These are projects that happened in sections of 3604 and 4605 that were taught by me. Other sections will certainly do different projects. The principal reason for showing you these projects is not to show you specifically the projects that you will do in these courses, but rather to give you a general feeling for what general kinds of things you are likely to encounter in these courses. So, first, here is an HF transmitter project from 3604. This is a project that students do in several stages. First, an oscillator, which is a signal source. Then they design a buffer circuit, which is designed to interface to a power amplifier. And then finally, these things are integrated into a single device. These images are from a student project report. You can see that the students design the circuit, they build it, and here is the constructed circuit, and then test it. And here is an example of that testing. In this case, the student has demonstrated a proper 125 milliwatt 7 megahertz transmitter that uses a crystal-controlled oscillator and a power-efficient Class C amplifier. Here's another project from the same section of 3604. This is a software radio-based weather radio. Again, this is a project that the students do in several stages. First, they design a low-noise amplifier, which is this thing here, also shown here. Then an RF block-down converter, which is all this hardware shown here. And then an interface to a USB-based software radio dongle, which is not shown here. Also, they develop a V-shaped dipole antenna, and that's also not shown in this slide. Again, these images are taken directly from a project report that was submitted by the student. Here's some hardware from 4605, which is one of the courses that follows on from 3604. In this case, in this particular section, I developed a circuit board for the students to use. That's shown here. That circuit board includes an RF integrated circuit, which is used to down-convert the FM broadcast radio band to an intermediate frequency of 10.7 megahertz. And that's subsequently digitized using the software radio dongle. The students assemble and test portions of the circuit as separate exercises throughout the semester, and here is a list of those exercises. And by the end of the semester, the students have a complete working SDR-based FM broadcast receiver. This display over here shows a signal from WUVT, that is the Virginia Tech campus radio station, being captured and analyzed by this system. Now, this is not a project per se, it's simply a series of lab exercises that's used for teaching and demonstrating relevant concepts. In the next few slides, I'll show you some of the projects that students did in the same section of 4605. In this project, the student team started with the original analog RF design from the previous slide, and then added a modern low-noise amplifier, shown here, improved the selectivity of the design by adding some additional filtering, and then replaced the SDR dongle with an analog FM demodulator chip, which is this part of the circuit shown here. Just to be clear, the students created the circuitry as well as creating the new printed circuit board, and successfully built and demonstrated this new radio. Here's another project from the same course. In this case, the students kept the SDR receiver back end, but came up with a completely new analog front end for operation around 460 megahertz. You might wonder what this thing is, hanging off the side of the circuit board. In this case, the students realized in the final days of the project that they would not be able to meet a selectivity requirement that had been imposed on the project. So, they came up with a very creative solution. They added this section of rigid coax cable, which creates a deep null in the frequency response at the frequency where their existing filter was inadequate. It's not a pretty solution, but it was a creative and inexpensive and totally effective solution to the problem. And that's the kind of problem solving and determination that we like to see in this kind of course. Before continuing, let me say just one more time that these are projects from the sections of the courses for which I was the instructor, and other sections will likely do quite different, but certainly equally worthwhile projects. My intent here is merely to give you some idea of the kinds of tech that you could expect to encounter in these courses. A good reason for taking 3604 or one of the follow-on courses is in order to prepare for a senior design project that involves RF concepts and hardware. With that in mind, I'd like to show you one example of such a senior design project. In this case, the students designed and built a spectrum monitoring system for 20 to 200 megahertz. The 5 subsystems comprising this particular system included the antenna, an RF block down converter, a digitizer DSP board, a PC-based analysis system, and also a power distribution system, resulting in this complete system here, which was successfully developed and tested. So, if you're interested in a project like this, you can see how having some background in RF would be useful. So, to conclude, let me say that we hope you can join us, and we're available to answer any questions that you might have. You might also consider checking out the description for this video for additional information, especially for information that becomes available after this video is released. Finally, remember that there is a separate video available that talks about RF and microwave engineering as a career. That may appear here as a link on the screen right about now, or for sure you can find a link to that video in the description. Thanks for watching.